Good morning, everyone. Today's conversation is about space, innovation, and mission impact. How we get cutting-edge technology from being an abstract concept to delivered capability for our warfighters faster. Lockheed Martin's Space Ignite organization is taking on that challenge, bringing the agility and creativity of the commercial innovation world into a heritage defense enterprise. It's about blending two mindsets, the startup pace of rapid innovation with the precision and reliability demanded by national security missions. As space becomes the connective tissue of modern warfare, linking sensing, communication, and command and control, the real test isn't just building systems that work, but delivering them quickly, reliably, and at scale. To help us unpack that transformation and how it's happening, we're joined by Dr. Eric Smith, a director in the Space Ignite group at Lockheed Martin and the company's space AI lead. Dr. Smith, welcome.
Thank you.
Dr. Smith, Space Ignite was created to bring startup speed to a heritage space enterprise. From your perspective, what does that actually mean in practice? And how is it changing the way Lockheed Martin connects innovation to operational outcomes?
So thanks for the question, and thanks for inviting me here today. It's a real honor and a pleasure. When we think about a startup culture, we think about speed, but we also think about a relentless desire to innovate. This tireless pursuit of pushing the boundary of what's possible in a development cycle of learn fast, fail fast, and repeat until you succeed, you pivot, or you just move on. And that kind of culture really has been in the Lockheed DNA since the Corona days, the first successful ISR mission that on its first day collected more film of Russian territory than the entire YouTube program up to that point in time. And we continue that innovative spirit today with programs that we talk about and we all know about, like F-35 and F-22, GOES, MUOS, GPS, and so on, and a whole host of other programs that we don't talk about. And the government in those programs is a very exacting customer. We go through line by line, cost element by cost element, justifying why something costs what it costs, why certain pieces of the program have to exist from a, say, risk perspective or performance perspective. There are detailed mission requirements that ensure that when this hardware fills its place in the battle space at some point in the future, it's going to perform as expected and integrate with other systems and workflows and tradecraft in a way that really adds the value that we need from it. But one thing that we did hear loud and clear from the government in the recent past is great technology, great capability, but in the future we've got to have it a lot faster and we need it at scale. And the at scale piece is going to also mean lower costs through lower NRE and standard processes for things that we build many copies of instead of just one at a time. And so yeah, this is the origin of Ignite as one of the whole slew of initiatives across the enterprise to attack that speed and scale question. So Ignite specifically was built from what I think of as three major organizations in space. There is the Advanced Technology Center, that's the heritage innovation engine for space. The group that works on internal research and development dollars, partners with government science and technology organizations, universities and small businesses with a mandate to rapidly transition technology from the labs to the lines of business for integration and eventual delivery to customers. So that's that core innovation piece of Ignite. And then we've combined that with directorates that hold scientists and engineers and program execution experts in essentially every major domain that one needs to design and deliver space hardware. Optics and modeling and simulation for digital twins of environments and digital twins of hardware, active communication or active sensing, including quantum sensing, communication, edge processing, radar, platforms, AI, autonomy, all of these organizations with the expertise to build and deliver, plus an organization that has as its mandate rapid development and deployment for these new ideas. So the innovation engine, the domain expertise and program execution, and the rapid deployment to demos all under one roof.
So far, what do you consider some of the most important factors in successfully blending that commercial culture with the defense innovation cultures? And what have some of your greatest successes been?
I think the most important piece of blending those cultures is a shared commitment to success. And we really have that in Ignite. So it started with the government. We've got to have this capability at speed and scale. Lockheed Martin executive leadership said, yes, we agree. We're going to implement the following structural changes to make that happen. We have organizations that now have a common vision, a common mandate under one leadership chain and resources and legal, S&BD, strategy and business development, finance and business operations, contracts, all under one roof to remove any barriers that might have prevented speed and scale in the past. And we have scientists and engineers that are doing the day-to-day work that are completely bought into that vision. And so that shared commitment to success is creating the culture that I think will make us successful. What are some of the successes? So I'll first say, how I see space in the context of the battle space. Space, I think, will be the fabric through which every element of the battle space will run. As an example, we have a product at Lockheed called Command IQ. And what does Command IQ do? It provides mission and dynamic planning, ISR planning and collection, dynamic targeting, sensor management, track management, threat evaluation and weapon assignment, course of action generation, and an AI decision engine. And to provide that breadth of capability, one has to have a persistent and near real-time picture of the entire battle space. The SDA's proliferated warfighting space architecture provides that kind of persistent, near real-time access of the battle space in a missile defense scenario. So on October 15th, Lockheed delivered its first 21 Tranche 1 transport layer satellites as part of that real-time, complete, persistent view of the battle space for that warfighting architecture. And why is that relevant in this discussion? It's because those satellites came out of a new facility that Lockheed built called the Satellite Processing and Development Center, which was built specifically to take advantage of scale and speed.
Perfect. So following up on your idea that the space is the new fabric or the new connective tissue for modern warfare, how exactly do you think that should shift how the Department of War is thinking about space as part of the joint fight? And how does that shift how you and your group are thinking about how you design and build space systems?
So the government ought to be thinking about space as the ultimate high ground, but with all of the traditional advantages of a military high ground. So imagine being able to query the state of the environment in real time anywhere on the planet. And the environment being, of course, things like temperature, precipitation, wind speed, cloud cover, but it's also who's there, what are they doing, where did they come from in the recent past, and what are they likely to do in the future, such that one can deliver assets, resources, effectors to places on the planet that are contested or otherwise difficult to navigate. Deploy sensors, medical equipment, weapons quality, targeting data, over the horizon, even as events are unfolding in real time. So space should be thought of as a layer wherein vast amounts of data are collected and actionable intelligence, and where it's appropriate, directly action is generated. In order to do that, space is also going to have to be a distributed high-performance compute platform, where using that data, a world model is created and maintained to provide context when generating things like relevant course of action in a given conflict scenario as it's unfolding. How does that change the way we think about designing space hardware? The Lockheed objective is 100% mission success. And we really think about that in terms of the mission, not just the particular piece of hardware or software that we're delivering. It's 100% mission success. And in a scenario where we're talking about scale and rapid delivery, one can achieve mission success through something like a proliferated, attritable constellation of satellites with redundant sensors, computing, and communication. And so in the past, we might think about mission success from the perspective of a large, complex, high-value system that is situated in a critical piece of the, say, command and control chain in a conflict scenario. And what are the ways in which this can be disrupted, and what are our few options for mitigating that versus a highly proliferated, attritable, redundant system wherein your options for mitigating conflict are now much richer and more interesting.
Absolutely. You've worked closely with both commercial startups and defense programs in your career. What lessons from the commercial tech world are the most transferable to the space and defense enterprise, and which simply don't fit?
So let me talk about Google X in particular here. So, if you go spend a day in the Google X building in Mountain View, and you spend a day in the labs in Palo Alto or Sunnyvale at the Lockheed Martin facility, you will have two very different experiences. In Google X, there is it seems like a near constant celebration of ideas. There are, where possible, the labs are completely open or behind walls of glass so that you can see what's happening on the inside. You'll be sitting at your desk doing your work, and there might be a robot from across the building that comes to your desk and offers you treats in the middle of the day. There are walls that are covered with milestones for programs that were born and died or transitioned out of Google X into some other startup company. There are sketches of just crazy ideas that either were proposed or are in the process of being proposed, kind of written out on the walls, and some of them just really are crazy ideas, but they're really celebrated. And so there's just a culture of celebrating innovation. At Lockheed Martin and other aerospace and defense companies, that the need and the spirit of innovation is there, but we also have real life and death problems that are in front of us that we're trying to fill for the government. We know there are gaps in technology, gaps in capability. There are expected future threats that we have to counter and work quickly to make sure we can counter those. And so while we have that same innovative culture at Lockheed and other aerospace and defense companies, the first question that we ask is, that's great, but how does it fill this particular gap today that we absolutely must fill? And so there's a sense that in a Google type culture, it's a culture of yes, and in a Lockheed culture, it has a feeling of a culture of no. It's a great idea, but this is what we need to be focusing And so I'd like to find a way to transfer that culture of yes into aerospace and defense without losing track of what we absolutely can't lose track of, and that is the needs of the warfighter today. What doesn't transfer quite so well in my mind is the concept of a well-defined product. And how commercial companies versus aerospace and defense companies view products. And Lockheed, of course, has products. We have an entire product center whose purpose it is to make sure we drive consistency in cost and schedule and performance for things that we build many copies of. But that's not the way that the commercial world thinks of a product. So we'll go back to Google X and think about Waymo. Waymo's product is transportation as a service. And they own all of the systems engineering and all of the technology. They own everything that comprises that product. And when a Waymo car and a Zoox car see each other in San Francisco, they don't share data, they don't talk to each other. The Zoox car doesn't have the benefit of the history of the Waymo car in terms of what it's planning to do in the future or what threats might be out there. The Waymo car isn't integrated with the traffic control system of the city. It's not integrated with the emergency services in the city. They have a very well-defined area of operation, rules of behavior, business model, cost model, and so on. Aerospace and defense, on the other hand, we're really delivering capability into the product, which is an increasingly interconnected military of the US and its allies. And while we compete with companies like Boeing and Raytheon and Palantir and Anduril, our job is that when we win one of those contracts, we're delivering the product in a way that isn't competing with Raytheon and Boeing and Anduril and Palantir. We're there to integrate, leverage their strengths, and fill gaps such that the overall product, a world-class fighting force of the US military, is as efficient as possible.
Absolutely. We've seen a real explosion of commercial activity in space. Where does Lockheed Martin see itself in that ecosystem, both today and in the future?
So we are actively, we're actively and constantly on the lookout for small businesses that are developing new technology that we see aligned with our business interests. So we have a Lockheed Martin Ventures company up a corporate, invested something like $230 something million in the last decade to make sure that businesses that we see as adding value to the aerospace and defense industry are funded and guided in a way that ensures their success. So Lockheed, as a, we have been a system integrator historically, and a system integrator can't really be an effective system integrator unless you understand the details of the technology that you are integrating into some capability that you're transitioning out. So we see ourselves as partners with that upcoming ecosystem.
Excellent. And finally, what do you see as the most important technological breakthrough or organizational change necessary to maintain U.S. dominance in space?
So that has to be AI and autonomy. AI and autonomy. I mean, the explosion in AI capability that we've seen since the 2017 Google paper on the attention-based transformer and the resulting large language models set up in this agentic architecture that can reason in a way that fairly well mimics the way humans can reason and decisions that they can make. Partner that with the physics-informed neural networks and reinforcement learning approaches that helped Google and Dan Baker at University of Washington win the 2024 Nobel Prize for solving this 50-year standing problem in protein folding, and couple that with autonomous systems that are already pretty mature in defined environments. We can fly helicopters and combat aircraft and drive cars and underwater vehicles all autonomously with great effect. And combining that with AI is going to be a force multiplier like we've never seen before.
Well said. Thank you so much, and fascinating insights.
Thank you.